Everybody's working on that first picture. So you should have gotten this third side to be 4 radical 2, which you probably did the Pythagorean theorem. And you probably got this little angle in here to be 45 degrees. There's a couple of ways you could have done, lots of ways actually you could have done that. I said that tangent of alpha was opposite over adjacent, and then worked it out from there and did arctangent, got 45 degrees. Then I took this whole thing, and that whole thing is 225. You also could have said sine of alpha is opposite of hypotenuse. You could have said cosine of alpha is adjacent of hypotenuse. You could have said, oh, I can see this ratio. It's actually 1, 1 radical 2, and I know that that reference angle is 45. Any of those would work. And that's kind of what we've been doing up to this point, and those are the words we've been talking about. Starting today, this little guy right here is a vector. Alrighty? So, let's start with some terminology here. Scalar. That talks about the magnitude of a quantity, and you're looking at that going, I don't even know what that means. For now, when you see the word magnitude, I want you to think about the word length. Magnitude, just kind of replace it in your mind with the word length. We'll talk a little bit more about that in a moment, and that can be expressed by a real number. A vector is a directed line segment. It is a vector when it gives direction and it gives, we'll just put length for lack of a better word for right now, we'll just call it length. It's magnitude. It gives direction and length. A vector not only says, you know, it's 50 meters long, but maybe it gives a direction. Maybe it's 50 miles an hour going east. That would be a vector. And that word pops up a lot. You probably are thinking maybe things like aviation, or maybe you haven't been around enough of that to know, but Mr. Major, and several of you guys have him for class, he's a private pilot on the side, and we he flew us up, I don't know, just like a couple weeks ago, and we went and saw my grandpa, and he had his maps out, and he's talking about vector this and vector that and all of that, and that's what he was referring to as this right here, speed and direction. Airspeed, ground speed, temperature, all of that stuff. So that's what that's kind of, that's where that's going to come into play. There's lots of ways to use vectors, but that's the one that we use in our house most, just because he flies. Consider vector OP. Sometimes it's written with a little ray over the top. O is the initial point, because that's where it's starting from. P is called the terminal point. Now, terminal usually means end, right? That's what it means. It means end. And you're looking at that going, well, that's an arrow. Doesn't that mean it goes on for forever? Usually, today it doesn't. Today, this is just telling us that the direction is this way. P is an ending point. So that arrow just gives us the direction. Magnitude, like I said, we're going to think about that in terms of the length. The length of a vector, it's expressed as the absolute value of P, or it could have double bars. This is how they write it. And I think they probably got that from this right here. When you did the Pythagorean theorem right here, Why didn't I put plus or minus for radical 2? Because it's a length, exactly. So I think that's probably how that started. So when they're talking about magnitude, they usually put absolute value bars around it. And that's just kind of how they write it. That's its name right here. This is the name of the magnitude. This length could refer to distance, which is what we're used to talking about. The length of something from one end to another. It could be talking about speed. Could be talking about force. Could be talking about acceleration. There's lots of things that could be. You're going to see these three things show up really for the next chapter or two. Could be distance, could be speed, could be force. Two vectors are equal if and only if they have the same magnitude and the same direction. You can look at this guy down here. As you can tell, it says magnitude of OP equals the magnitude of PO. That's true, but that's not an equal vector because one of them is going this direction and the other is going the other way. So these are not equal vectors. Any questions so far? Okay, next page. Just lots of stuff to read here. Aren't you glad I didn't make you write all this? You're welcome. The sum of two vectors is also a vector. It makes another vector. The vector sum A plus B, where A is a vector and B is a vector, is called the resultant. You're going to see that word a lot. Resultant. And together it makes this vector right here. There are two ways to represent the sum of two vectors. There's this one right here where you put the tip of A next to the tail of B, and then end to end, that's the vector. Or there's this parallelogram sort of method that a lot of people use, where they take vector B and they slide it over here so that this side is congruent to this side and this side's congruent to this side, and then you're looking for the diagonal of that parallelogram. It's the same thing, basically. Scalar product. The scalar product of real number k and a vector u is k times u, with magnitude k times the magnitude of u. So you'll notice that these vectors are usually kind of written in bold. And I kind of got lazy last night. It kind of got late, so I quit putting them in bold. Just know typically they are. You can kind of tell I got a little lazy. This is u right here, vector u. If you have 2 times u, it's double the length. And remember, that could be speed, could be force. If you have 3/2 of u, it's just 3/2 of the length. Half of u, notice, is half the size of u. Negative 2u. Yes, it's double in length, but what else is different? Right, this negative makes it change direction. Changes the direction. Okay, the numbers a and b are the horizontal component and the vertical component of vector u. Here's kind of what that means. Up until this point, you guys have been thinking of things in terms of x comma y, or you could call it a comma b. For this vector, it's going to be written the same way with one exception. And I don't even know what these things are called. Mr. Major probably knows, but I call them pointy parentheses. That tells you it's a vector. That tells you that is not a point, it's not an address. That is a vector. And that would be where it ends. Where the first component is the horizontal component and the second one is the vertical component, just like x comma y. The positive angle between the x-axis and the position vector, that's this guy right here, that's theta, is called the direction angle for the vector. We've been referring to this as kind of an angle in standard position. It's the same thing, but our new term for it is the direction angle. If you kind of look at your triangle here, we had to go over A and up B. So this distance is A, this distance is B, and this, we've been calling that a hypotenuse. That's going to be the magnitude of vector u. Now kind of keep this picture handy. We're going to flip back and forth just a second here. It says that the magnitude of the length of vector u is a comma b, and it's given by this right here. And you're going, oh great, a whole nother formula to memorize. But don't you already have that memorized? isn't that really kind of like a squared plus b squared equals c squared, where c, that's our hypotenuse, right? So we call that u. And then if you square root both sides, we have the square root of a squared plus b squared equals u. You already know it. If you want to memorize that, go for it, but you kind of already know it. Down here, the direction angle theta satisfies tangent of theta is b over a. Now flip your paper. Tangent of theta is b over a. Again, if that's a formula that you want to memorize, that's fine. Or you could just draw the picture and then do tangent the way you know to do tangent. Okay? And it says where a can't be 0 because it's on the bottom, obviously, but just so you know, it is possible for a to be 0. You just won't be able to solve for that direction angle. Okay? Not using tangent anyway. The horizontal and vertical components, a and b, respectively, of vector u having a magnitude or length of u and the direction angle theta are given by, now these are formulas, and again, you already know them. Let's think about this. This says a equals the magnitude of u times cosine of theta. Flip your paper over. Write this out with me. Cosine of theta. Cosine's what over what? Adjacent over hypotenuse. So a over magnitude of u, right? To get a by itself, we multiply both sides by the magnitude of u. And ta-da, there's one of the formulas it gave you. Sine works the same way. Sine of theta is opposite over hypotenuse. To get b by itself, we multiply both sides by the magnitude of u. And ta-da, it's the next formula. So if you want to memorize them, it will make your homework just slightly faster, but you already know them. Questions? Everybody okay? All right, flip, flip. Vector operations. For any real numbers, a, b, c, d, and k, notice if you have two vectors and you're adding them together, you just add the horizontal components and then add the vertical components. Not a big deal. If you have a scalar of a vector right here, k times a comma b, it's kind of like distributing. K gets multiplied by both of them. If you've got a vector u and it equals a comma b, the negative u, you just take that negative and it's kind of like distributing it a little bit. Subtraction, same kind of deal. You could skip the middleman here and just say a minus c and b minus d. Notice what we're missing here is multiplication and division. Multiplying two vectors and dividing two vectors. Unless she changes her mind, and I'm not sure why she did this, but Ms. Zangler pulled that from the curriculum. It's called dot product. Did you guys do that in physics? No? And so maybe she'll add it in later. I kind of doubt it. For whatever reason, she doesn't think that you need it for next year in calculus. So maybe you'll be introduced to that next year. I'm not sure. It's not that big of a deal, but we did not include that on here, just so you know. So the portions that cover that in our textbook, we're not covering. All right, let's scooch down. Now we're on examples. That was all of the precursor stuff. Here's what we do. This is to find the magnitude and direction for direction angle, for vector u, and here's the terminal point, basically, if you want to think of it like that. So let's draw it. It's going to be in the second quadrant where we go back 5 and up 4. And there's the vector right there. Now we are used to little triangles. And this side got us negative 5, and that side got us 4. They want the magnitude of u, and they also want the direction angle, which remember is that big guy right there. So, to get the magnitude of u, can't we just do Pythagorean theorem? Yep. So the magnitude of u, or you could use the formula, equals the square root of the a squared plus the b squared. Whoops, I actually wrote b, sorry. And I believe you get radical 41, is that right? Terrific, so we found the magnitude. Any questions for how we did that? What's another word for magnitude? Length. Just in your head, be thinking length. Direction angle. Okay. I probably am going to have to find this reference angle first. Tangent of alpha is opposite over adjacent. You have a calculator. Somebody type in arctan of -4/5. What is it? -38.7-ish? Yeah. Which basically means that this is, the reference angle itself is 38.7, right? Yeah. So if this is 38.7, how do you get the direction angle? Yeah, 180 minus 38.7, which I believe is 141.3. Do we have to use tangent? Nope, I used sine this morning. Sine of alpha is opposite over hypotenuse. You could do that as well, or cosine. Questions on the first example, because the whole first part of your worksheet looks just like this. Terrific. Next, vector v has a magnitude 14.5 and a direction angle of 220. Find the horizontal and vertical components. So you're looking for x and y, basically. So we draw 220 degrees, and that's down here in the third quadrant, right? Yeah. And this whole angle right here is 220 degrees. The magnitude, length, is 14.5. So we draw a little triangle. What is our reference angle here? 40, good. But I don't know are the lengths of these two sides here. How am I going to get them? They're the formulas that we talked about before, or you could just kind of use SOHCAHTOA on your own. Isn't the sine of 40 b over the hypotenuse? So sine of 40 degrees equals b over the magnitude of v. Multiply both sides by 14.5. And what do we get? 9.3. However, we're only almost there. What did we forget? Didn't you have to go down? So it's negative. Watch your positives and negatives, friends. All right, how do we find A? What do I do? How about cosine of 40 is adjacent over hypotenuse? So 14.5 times cosine of 40 degrees equals A. And notice these guys right here, those are those formulas we looked at earlier. So A is? Hello? Nice job. 11.1, but is it? Negative, because you have to go left. Good. So we found the horizontal and vertical components. Do you remember how to write them? Pointy parenthesis, A, whoops, that's a point, sorry, comma, B, close up the pointy parenthesis. I need to know what those things are called. I really don't know. All right, any questions on that example? Can everybody handle that on their worksheet today? All righty, moving on. Write each vector in the form of AB, where it's got pointy parentheses around it. This is just like the one we just did. So I'll tell you what, this group right here, Cameron's whole group, you guys are going to do vector U. You guys in the middle are going to do vector V, and you guys over here on the right are going to do vector W. Go for it. You two, be nice. Mm-hmm. drew it weird, didn't I? It's probably dumb. Sorry. I was like, wait a minute, something's up here. Oops, cosine. Third group, I don't have my calculator in front of me. So when you type in 10 times cosine of 20, what'd you get? Okay, and what'd you get on B? Gotcha. Okay, so the first one, first group, here's what they did. I'm hoping I got this right. Here's kind of what the picture looks like. That was a 45-degree angle is what it made, was the reference angle. And you know what the sine, and I should have put cosine on this one, sorry. You know what the sine and cosine of 45 degrees is. So you can just type it, or just in your head, think radical 2 over 2, and you get 4 radical 2 and 4 radical 2. Of course, A is negative, so we made sure to make that a negative. V was a little trickier. Started drawing the picture and then realized that was goofy. 270 is 3/4 of the way around. It's right here. So we're thinking about our little terminal point down here. 0, negative 4, because the magnitude is 4. And for W, it's all the way around here in the 4th quadrant, which means B is negative. We don't know anything about the sine and cosine of 20 degrees without a calculator, so you had to work it out with a calculator, and you get 9.4, negative 3.4. Questions on any of those three? Is everybody okay? All right, I'm going to keep going. Find the magnitude and direction. So how many answers are we looking for? 2. Find the magnitude and direction of the sum of two vectors, u and v, and they give us the magnitudes. And they tell us the angle between them. So here we go. Here's vector u, and it says that u is 6.9, and v is 13, and between them is 48 degrees. They want to know the sum of those two vectors. They want the magnitude and direction of the sum of them. Well, some of you are probably thinking, well, she gave us like operations and what we could do right here. Can't we just add them together and make it real simple? They didn't give you this information. They didn't give you that at all. They just gave you magnitude and direction. So we're going to do that parallelogram method where you take this side right here and you shift it over here so that you've got tip to tail, and kind of close it up over the top. And this side is now also 13. And then they're looking for this guy right here. We're going to call it W. That's what they're looking for. That's the magnitude. And they also want to know this theta. Now please listen carefully. A bunch of you in here right now are super tempted to divide 48 divided by 2 and call it done. You cannot necessarily do that. The way we drew the picture, it looks like it bisects it. It doesn't bisect it every time. If it does bisect it, it's just one of those rare ones where it actually worked. Alrighty, so do not cut that guy in half. That's not what's happening there. Even though our picture kind of looks like it this time. I do want to show you something though. I'm going to extend these guys a little further. And when I do that, do you know what this angle is right here? How do you know it's 48? What are those called? Corresponding angles, right? We've got parallel cut by transversal. So that's 48 degrees because those two are corresponding angles. If this one is 48, what's this one? What is it? 132. How do you know that? Yeah, they're supplementary. It's 180 minus that. So I've got a side, an included angle, and a side. And I need this guy right here. How are we going to do that? Can we do like sine or cosine? You better be saying no. How come? Why can't I do sine and cosine? It's not a right triangle. It's not. You're going to have to use law of sines or law of cosines. So let's remind ourselves of the law of cosines. I want this side, so I'm going to put w squared equals one side squared, so 13 squared, plus the other side squared, so 6.9 squared, minus 2 times the first side times the second side times what? Cosine of the included angle, 132 degrees. So type all that in your calculator and then square root it. What did we get? I heard it, 18.3. So there's our magnitude. Now we need the angle. This guy down here. You guys see this whole triangle? And now we know that this right here is 18.3. How can I get it? Love it. Let's do law of sines. Christian, pay attention there. All right, so we have 18.3 over sine of 132 degrees. Whoops, that's messy, sorry. Equals 13 over sine of theta. Let's solve for theta. Don't forget to do arc sine. Anybody got it? 31.9 degrees? Yes. So we have our two answers. We found our magnitude and our direction angle. Questions? Yes, ma'am. It's always going to be kind of the, how do I say? It's going to be the one like if this was the x-axis, it's kind of like the one that's in standard position. Does that make sense? All right, flip the page. We're getting close. Two forces of 32 and 48 newtons act on a point in the plane. If the angle between them is, between the forces is 76 degrees, find the magnitude of the resultant vector. Resultant meaning you're adding those two vectors together. So the first one they give us is 32. The next one they give us is 48. And the angle between them is 76. I'm going to keep talking for those of you that need it. Try to work this one on your own. You're looking for the sum of the two vectors, the magnitude of it, just like we did on the page before, on the problem before. But I'm going to keep talking because some of you need that, and that's okay. I'm going to take this side right here, and I'm going to scooch it over. And I've got my little parallelogram now. Got tip to tail. This side is also 48. And I know that I'm looking for the sum of the vectors, so I'm looking for this diagonal is what I'm looking for. Well, I've got this angle and two sides, but I need two sides in the included angle in order to pull off the law of cosines. So this angle and this angle are supplementary. So 180 minus 76 is going to be 104. So now I can do law of cosines. So w squared equals one side squared plus the other side squared minus 2 times one side times the other side times cosine of the included angle. We type it in our calculators and get the square root, and we should get 63.8. And that's it. Newtons, I guess I should say. Everybody okay? Last three, and these go fast. We've got two vectors, u and v. It wants us to find the following. First one, it just says u plus v. So you add the horizontal components. Don't forget the pointy parentheses. So 6 and negative 14 is negative 8. Negative 3 and 8 is positive 5. And that's it. Questions? Great. Next one, negative 1/2 of v. This one's v. Don't forget your pointy parentheses. Bless you. Negative 1/2 of negative 14 is positive 7. Negative 1/2 of positive 8 is negative 4. Close it up. You're done. Last one is 2 steps. 5 times vector u plus 2 times vector v. So you have to do the multiplication first and then you add them together, just like normal order of operations. So 5 times u is going to give us 30 comma negative 15 plus 2 times v is going to get us negative 28 comma 16. And now you add them together so that you get vector 2 comma 1. Don't forget your pointy parentheses. Questions on any of this, you guys? New terminology, but it's old stuff. Okay? Alrighty, let me pass out your worksheet.